Good evening, everyone. I'm Sashi. I'm the moderator for this webinar. Thanks for joining us today for a very exciting webinar on Spock. Uh, I know it's a rainy few days here in India, but what better way to spend your time indoors than to learn something new and exciting? For those who are joining our webinars for the first time, a very brief introduction to start off. At start off, we seek to match people with work more efficiently. So that's our broad vision statement. Currently we're focusing on building a vibrant Java community where you have interesting career opportunities. You could discover engaging learning resources. You have lots of opportunities to network with experts and seek their help. We're trying to integrate all of these together to help people become more productive and move up in their careers. With our webinars, especially, the idea is to get the really bright lighthouse speakers, the creamy layer of the tech world, to talk about cutting edge topics, frameworks and tools, and so to speak, in a way to sort of get people excited about new technology, and then show them a pathway to learning those new skills and becoming more marketable in the job market, and also more broadly becoming more productive at work. Leading today's webinar is Ivan Martin Lopez. He joins us from Madrid, Spain. And very quick introduction about Ivan. Ivan is a software engineer and a systems administrator with over 15 years of experience. He contributes generously to open source projects. He's a core committer of Micronaut at Object Computing Inc. He discovered Grails and Spring a long time ago, and since then he develops almost exclusively using Java and Groovy. Like we say in the programming world, it's love at first line. Evan lives in Spain. He's also the coordinator of the Madrid Groovy user group, the former organizer of the Greech conference, and a frequent speaker at the conferences like Devoxx, Geekon, Spring IO, Riga Dev Days, Java Crow, Spring One, 2GX, and GreatConf. Evan, thanks for joining us today. We're so privileged to have you join this webinar.
Thank you very much for having me today. It's my pleasure to be here talking about the Spock. So let me share my screen and we can start.
A very quick introduction, Evan, I'm sorry I'm interrupting you, but
Sure.
For those who joining, as we all know, software development teams are becoming more complex. We have people with more diverse skill sets, multiple people working on projects, committing code to repositories and things like that. On the other hand, you have release timelines that are shrinking. What used to be a monthly release cycle has now become a fortnightly release cycle, which will soon probably become a weekly release cycle. So all this increases the chance for fault, and it's very critical that testing is integrated into the development process. It's not something that's done at the end of the development, but it's something that's done along with the development. So frameworks like Spock make it easy for such integration to happen. I'm sure you must have heard about Spock. It's a testing framework for Java developers, Java and Ruby applications. And what makes it stand out is its expressive and simple syntax. So what you can do with JUnit in like 10 lines, you could achieve the same thing with about 4 to 5 lines in Spock. So in that sense, I think this session will focus exclusively on Spock. We have allocated 15 minutes for a code along demo by Evan, and we have 10 minutes at the end for Q&A. And should the session run over, we will still take it up to like 6:10 p.m. Sorry, 7:40 p.m. India time, and then we will try to squeeze in as many questions as we can. So with that, Evan, you can now begin. Thank you.
Sure. So let me see. Can you see my screen?
Yes.
Perfect. So yeah, we're going to talk today about the Spock. And as you said, the Spock is a Groovy-based testing and specification framework for Java and Ruby applications that makes writing tests like fun, right? Because Sometimes we don't write tests because it's boring or it takes a lot of time, or we don't really know how to do that. So with Spock, we can write beautiful and highly expressive tests because it has a really nice DSL, and you can also use all the power that Groovy provides us. And it's important that because when you write tests, you also need to maintain tests, right? It's not like you focus only on production code and make sure that it's readable, you can refactor and do a lot of stuff. It's also important to be able to maintain those tests and make them readable and maintainable. And with Spock, you write less lines of code, and you will see all the things that you can do with Spock. Spock is totally compatible with JUnit. Actually, the new version, it's built on top of the new JUnit 5 platform. So everything, or in every place or tool or whatever, you can use JUnit 5, you can use Spock. It has support for IDEs with IntelliJ, Eclipse, and NetBeans. And in tools like Gradle and Maven, you can use in your CI environment. It works pretty much everywhere. So what I'm going to do in this talk is show you a lot of examples of the things that you can do with Spock. I could have spent like 20 minutes talking about why it's important to test our applications, explaining a lot of theory and all that stuff. But instead of that, I'm going just to assume that you all test your applications, and you know, at least if you don't test your applications, at least you know the benefits of testing your application. So as I'm a developer, I like to see and I love to see code. So what I'm going to do basically is show you code, right? So let's go to the IDE. I have here a project with some Java code that I will be showing you during the demo and some tests. So the first thing you need to do if you want to start using Spock, I'm using Gradle, but you can use Maven if you want. You can see that the build is pretty simple. I apply the Groovy plugin, Maven Central Repository, and 2 dependencies. Latest Spock version and latest Groovy version. And as I said, Spock used this new JUnit platform. So that's all you need for start testing your Java application with Spock. So I have this example. It's plain structure, source main Java, and source test Groovy. And I'm going to show you different things that you can do with Spock. Let's start for the very beginning. The first thing you need to do, or you need to see, is that every Spock test class stems from this specification. And in this specification, you can see it's annotated with this JUnit platform test table. And this is where all the glue and everything happens. But you don't need to worry about anything like this. You can just use it. You stem from the specification, and that's all. And the first thing that you can see if you are used to write JUnit 5 test is that you can write the thing that you are testing in plain English, right? It's not creating the method with camel case, should reverse a string, which is complicated when you want to explain something. You can just write plain English. And the next thing, well, by the way, I'm using Java 17, which was released last week. So you can see that it will work perfectly with Spock and with the latest Gradle and Groovy. So the first thing you can see is that Spock forces you to have this given when then BDD approach, right? In JUnit 5, some developers do something like this. Put this given when then in comments, trying to separate the different phases of a test. In Spock, this is mandatory, at least a few of them. There are a few rules. And this is the very basic structure. In the given, you put your inputs, you just set up your everything you need. In the when part, you say this is the subject under test, and in the then you put your assertions. And another thing that you can see here is that you can put also comments in plain English again, saying given a string when reversing it, then it's reverse. So this is what I'm going to do, right? I create a hello world. I'm going to call it reverse, and this is what I expect, the string reversed. And for all of you that are not very familiar with Groovy, you can still write Java code here. But for example, this reverse method, it's coming from Groovy. This is, you know that there is no reverse on a string, Java-lang string. This is coming from Groovy. Groovy adds a lot of methods and utility things to a lot of JDK classes for list, in numbers, strings, a lot of them. So you can see here the implementation, which will be what you will do in Java, using a string builder, reverse, and convert into a string. But with Groovy, you don't need that. You have a lot of things out of the box. And as I said, I'm using Java 17. I can use var since 11. And here in the then block, I put assertions. I don't need to put the word assert here. Everything that is a condition, like equals or not equals, will be an implicit assertion. So I can run the test, the very basic test, to see that it works. So let's see, it should pass. If Gradle wants to start. So you can see here green. And as I said, Spock forces you to use this given when then part. So this means that if I try to put here, for example, the then true, and I try to run the test again, it's going to fail, which actually it's not going to fail. It's not even going to compile. It's a compilation error saying you cannot use, then is not allowed here. Use one of these keywords, right? Because there are rules. And this is a way to kind of force developers to write the test in the right way, right? Not mix everything, the given, the when, and the then part. So this is the very beginning, given, when, then. But sometimes for simple examples, having this given, when, then is kind of verbose. So we have like there is a shortcut for that, which is expect. And it's read like you say, I expect when I reverse this hello world, that it will be hello world reverse, right? So sometimes you can combine given and expect or things like that. But you can see this is a pretty simple and readable test. So this is the very basic of Spock. Let's move to the next example. I'm going to show you how to test Java code. So I have this helper class, and I have here, remember, this is in source main Java, right? So all this code is Java. And here I have this method that returns some numbers of the Fibonacci sequence. And we can test it. We are going to interact with the lists. So I get the lists. Again, I'm using var everywhere. And then I basically check that when I add the next Fibonacci number, 21, the number is there on the list, right? This left shift operator is overloaded in Groovy. You can also use numbers add, which is the same thing that you will do in Java, and both work. So this is a pretty simple example, but you can do more things. So I have another example here. I have this user class, name, last name, getters and setters, nothing fancy here. And I just return a list of these 4 users, Sheldon, Leonard, Rahman, Howard, right? So with that in mind, let's go into, I'm going to put this here so we all can see everything at the same time. So I'm going to write some assertions about this list. Remember, again, it's Java code. So I can check that the size is 4 because there are 4 users in this list. I can get the names, and these are the names, Sheldon, Leonard, Russ, and Howard, in this exact order because lists are ordered. If I order them by name, this will be the new order, right? I can get the size of the last name, and this will be the sizes. So 6 is because Cooper has 6 letters, 10 is because Hofstadter has 10, Kutropolit 12, and Wolowit 8. And then I can get, for example, the name with the minimum letters. In this case, is Rush because it only has 3 letters, right? So this is how you can interoperability with Java code. And I think if you are not very familiar with Ruby, I think that you are wondering what that means. Users.name, and well, this curly braces is the way you define a list in Ruby. You could say here new array list or list of or whatever, it will be the same, right? But this user's name, if this is the first time you see Ruby code, probably this code doesn't compile in your head, right? Because users is what I'm returning here, and it's a list of users. But and then I'm like calling the name method on that list, which obviously it doesn't exist. So let me do this. Print line users.name, right? So basically what we are doing here is Ruby, it's calling the getter on every element on that list for us, and it's creating a new list with the result of calling the getter method. Even if I'm calling here name, you can see I'm accessing directly the getter, not the private property. But in Groovy, you can do here get name, or you can say name. But you can see that in list it doesn't work. This is called, this star here is a spread operator, and in this case is the same. It's been to apply something to the elements of a list. So this will print the same. If we want to make this code like more Java-like, another thing that we can do is we can create a new list, and we can say list name, right? Collect is the equivalent to the map method in the Java 8 Stream API. We can also say here, for example, something like user you name, or if I want to use the getter, I can say get name. Everything will be the same, right? And if you want to write this code in the Java way, you will do here the Stream API, and then you will call map, and you can say user you get name, and then finally you need to collect collectors to list, right? And now, since I don't remember if it was 15 or 16 or which version, we have this now to list, right? So I'm going to run this test, and we should see that basically the same output in all the cases, right? Because I'm doing the same, right? It passes, and you can see it's the same list. And probably you will agree with me that we can read this code. We do it every day. We understand it. But I think that you also will agree with me that it's more simple and easy to read, to maintain, and to understand this once you know how this works than writing this, right? So this is what you get using Groovy for your test. A lot of or less code to write and to maintain. So that was with a list, and we can do the same with a map. I have here a map, name, last name, age, and I return the map, again, Java code. And we can, let me do this so we can see it. And we can again do something on the map. I can remove the key name, and then I can check that the size is 2 because it only has now these 2 keys. I can check that it doesn't contain name, and I can access the last name in 3 different ways. Like this is dynamic Groovy. This is like in Java, and this is another way to access, right? And the last name will be the same, and the age. So I can run the test if you want, and it should pass without any issues. So with this example, you will be able to see, or you saw how easily you can test your Java code and use all the things that Groovy provides you, right? A nice way to interact with lists, with maps, and things like that. Power asset. So another important thing when testing is what happens when a test fails. Because what you can see, you want to really see why a test is failing without anything else, right? The test fails, you see the report, and you should be able to see pretty quickly why the test failed. Of course, this is going to fail because 6 is not the same as 20. But the important thing about this is this output that we will see here. So you see that when the test fails, we see everything or the value in every step to see why the test fails, right? Because 2 times 3 is 6, 5 times 4 is 20, and of course it's false. And I don't need to put a breakpoint. I don't need to put a lot of print lines to see why this failed. In this example, it's pretty obvious, but I have here another example for you. So you can see IntelliJ knows everything. This is a map. This is how you write a map in Groovy. Square brackets. This is the key, and this is the value. So name Ivan, age, child, and this is a list with this map inside it. And this test is going to fail because what I expect is that the name of the first child is Adriana, but it is not, it's Judith, right? Because this is again a list. So if I run the test, it's going to fail, but we will be able to see every single step why it failed. So you see here, okay, data contains basically everything, the hash map I created. Then I get the names. This is the same as calling data.getChild, because this is a map. So now I have a list of 2 maps without my childs. Then I get the names. This is what we use in the previous example. This is now a list of a string. And then the first element on that list is Judith. And I'm saying that it should be Adriana, right? So it's false and the test fails. And this is very important because, as I said, I don't need to put a lot of print lines here to check what was going on in every single step, right? And you also have this nice thing that Spock says that these 2 strings are like 14% similar, because you can see there are a few letters that matches, right? So I should say that they are more alike because they are both my daughters, not only 14% similar. But this is a really nice way. This is called, this output for an assertion, it's called power assert. And this was created at the very beginning in Spock. And then as it is so amazing, it was moved to Groovy core. So even if you are not using Spock, if you are using Groovy and you write assert something and it fails, you will see this power assert output. Okay, let's move to the next one, exceptions. So you want to test sometimes what happens when a code throws an exception, and you want to test different things on exceptions, right? So for example, this should throw an exception because I'm trying to convert this full string to long, and we know that this is not a valid long number. And I can check that when I run this code, it's going to throw a number format exception. So I can run the test, and the test is going to pass because this is the exception that has been thrown, right? It's green again. But you can do more things. So let me do this. I'm going to copy the test. Should not throw an exception. So what if I do this? 1, 2, 3, and I say not thrown number format exception, right? Now I don't expect it to fail, and it shouldn't fail, right? But what happens if I expect another exception? Imagine that here I'm expecting null pointer exception, and I run it. The test should fail, and it's going to fail, but it's going to tell us that we were expecting, what is it? We were expecting here. Expected exception was null pointer exception, but we got number format exception. So the test fails because another reason that an exception was thrown, but not the exception I wanted to check. And you can do even more things with this. Let's go back to number format exception, because you can assign this to a variable. So you can say var e, and then you can assert something on the exception. So you can say e dot message. Come on, and you can see that IntelliJ know that that is an exception, and you can see that there is a message, and the message is something like for input string foo, probably something like that. It failed because I missed the semicolon here. So you can see again that the power assert. I know why the section failed, and now it should pass again. So this is really important because you can use here your own custom exceptions. And if you have here more things like only the message, you put here anything you want and you need, and you can assert everything that you want when that specific business exception on your code was thrown. Data-driven test. This is, for me, this is one of the killer features of Spock. The equivalent of this for JUnit will be like parameterized tests, but they are not like this. So these are way more powerful, and this been around for, I don't know, 10 years probably. So this is the very basic example. What happens when you want to test the same code with different input, right? I want to check that a list of numbers or different numbers are even. So I do this. I define some variable here in the spec, and I define the same variable. And I use here the left shift and a list, and I put here different numbers. So what Spock is going to do, it's going to run this test 1 time per number, right? So it's going to run it 5 times, and you can see here the output. It passes because all the numbers passed, and you can see now this is new in Spock 2. that you have this expanded automatically all the values, because you can see if one of the numbers, if I put here a 3, you will see that the only one test failed, but you know why and what was the number, right? This one, the number 3. You can also use more than one variable if you want, right? I want to have the minimum of x, y, and I can do the same. But this is fine, but there is a better way to write this, because here we need to like work in column mode, right? For the first iteration, x will be 1, y will be 2, and the result will be 1. But there is a better way to write this code, which is like this. In a table, this is a data table, and now it works in row mode. Sorry, yeah, in row mode. So for the first iteration is this one, the second one, and the third one. And I can add a new one, and I can say something like this. And you don't need to worry even about formatting the table, because you saw that IntelliJ is smart enough to format the table. The test, of course, the last one is wrong and it failed. And again, you see all the steps here and why it failed. Another thing that you can see here is that I wrote this description should get the minimum of 2 numbers, but we can improve this. I can do this. I can put here has x, y, and result, which are the names of the variables. And then when I run the test, Spock is going to replace the name, the values of every variable in the test name, right? So you can see here, should check that minimum of 1 and 2 is 1. So if one of the tests fails, you will have basically all the values and everything here on your IDE, on your test report. This also generates like a unit, some nice HTML test report that you can see later. And the last thing I want to show you about this, doing this with your test, like creating more than one output, it's called unroll. In previous versions of Spock, you will need to use this unroll annotation if you wanted this output. Now this is by default, but you can also use unroll to define this. This is the test that I'm writing, and I can replace these values. And in this test, what I'm going to show you is that you don't need to put fixed values here. You can iterate over anything that it's iterable. So I have here this thing. So I have this file in my test resources class path, which is basically a CSV file, right? Name and last name separated by comma. And then what I'm going to do here, it's basically I'm parsing that CSV file in an ugly and hacky way. So this is for a test, so for a demo, and it's fine. But please don't do this for parsing CSV files on production. Use a proper library to do that. So what this is going to do is going to parse this file, and in every iteration, it's going to read one line, and it's going to put the name, Sheldon, and then the last name, Cooper, in these variables that I'm using here. And what I'm doing here, this as user, this is a Groovy trick, which is called coercion. And basically this means that I can coerce, I can transform a map into a new user of a type, right? Because I have this name, this last name, and I have this constructor. So Groovy knows how to instantiate this class and call and use the constructor or the setters to create that instance. So this user, you can see that I expect to be an instance of my Java class, and then I check that the name for that iteration is the one that I read here. So I can run the test. The test pass, you can see here the full names, right? And I can add a new one if you want, just to show you that I'm not cheating. I add my own name, and now running the test again, that there are 5, and this is the last one, Ivan Lopez, right? So this is really, really powerful. The where part, you can put complex things here. I use this a lot of times in my real world code, because it's way powerful and easy to test the same code with different inputs, and you have control of everything here. This is simple because I'm creating an object and kind of parsing this CSV file, but you can open here a DB connection, get some data, and iterate it over it and check whatever. And it's very, very simple and easy to do that with Groovy. So let's go back here, mocking, yeah. So another important thing when we are talking about tests or about testing is mocking things, right? In Spock, we don't need to add an external dependency. I remember you that the only thing I have on my class path is Spock and Groovy. So if I want to mock something, I don't need to add Mockito or PowerMock or any other external dependency. Everything is built in the framework, which is good. And I'm going to show you how to mock something. When I talk about mock, what I'm talking about is checking behavior, is meaning I'm going to run some code, and in that code I have a dependency, right? I don't want to run the real code for that dependency. I want to have like an empty object. What I want to check is that some method on that mocked object, that empty object was called. So let me show you what I have here for you. I have this interface, this notification service. Here I'm mocking an interface, then I will show you how to mock a proper implementation. So I have this notification service to send a notification, a user. I want to send the user a message. And then, because, sorry, remember in the when part, this is what I want to test. I want to test what happens when I create a new user. So this is, again, my production code. You can see it's pretty simple. Probably this can be final. You see I have my dependency. This can be micro, this can be a Spring. You have dependency injection, even this is plain Java. And you have this notification service, right? And you receive a name and last name. You create a new user, a new instance of that user. You put here your business logic, do whatever you want, but at the end you will probably store that user on the database. And once that's done, you want to send the user a message saying your user was created. So you call this dependency here, right? This notification service. So what I want to do when unit testing this is I don't want to worry about this in a unit test. I'm not talking in this case about an integration test. What I want to check is that this method is calling this collaborator with these parameters, right? To make sure that my test works as expected. And if I remove this code, I want my test fails. So this is what I'm going to do. I'm going to use this mock. This is again from Spock. You can see here Spock mock API. And I'm going to mock my notification service. I'm going to create this kind of empty object for my notification service, and I'm going to create my user service with this mocked collaborator. Then I call the method I want to do to create a new user, and this is what I'm going to check. I want to check that when I run this, my send notification method. Let me put this again so you can see both at the same time. I want to check that this method send notification, which is this one on the right, it's going to be called once and only once on my mock. And this underscore here means I don't care about the first parameter, but I want to make sure that the second parameter is user created, which is the same I have here, right? So if I run the test, it's going to pass. And then I'm going to modify it a little bit to show you different things that you can do with this and also make it fail, right? So it passed. But what happens now that I have this test that passes, what happens if I refactor this in the future and for some reason I forget to send the notification, right? So I commented this out and I'm running the test again. Now the test is going to fail because this basically you can see the error. Too few invocations for this. I was expected 1, but I got 0, none, right? So this is a nice thing because I want to make sure that I'm doing this properly, right? And there are more things that you can do with mocks here. So I said that underscore means I don't care. So you can say, well, if I don't really care about anything, I can say something like this, right? Put an underscore for every parameter. And the test should pass again because I commented this out. Sorry, I put the code back again. But sometimes you don't want to do that. You can say also, yeah, but you know what? I don't really care about the method. So I can put here another underscore. And you can also say, well, I have 2 parameters here, but what happens if this method has 6 parameters? I don't want to put 6 underscore. So I can say star underscore, right? like this. And then you can also say, you know what? I don't really care about any mock service. So I can put here another underscore, right? So this is kind of a weird thing. It's like an emoji, weird emoji, right? But so please don't do this. The only use case for this is when you put here a 0. So let me roll back this change. So this means that I want to check that this is called once. And then as I put the underscore, meaning I don't really care about anything, this means that I don't care about any other thing. I don't want to check, or sorry, the other way around. I want to make sure that nothing else is run, right? So imagine that I have here more complicated logic, and in some cases I send a notification, but in other cases I use another collaborator. And for one specific test, I want to check that only this thing is called. With this one, you can do that. You should put that at the end of the then. And as this is very common, and writing this is way strange, there is a shortcut for this, which is this one: 0 times whatever, right? So the test will pass again. And there is a lot of things that you can do. You can say, well, I want to make sure that this is called between 1 and 3 times. You can do that. There is a lot of things like this. You can check the Spock documentation. But you can do more things, because here I said I don't care about this first parameter, and this is because I can really access the user, right? This is a local private variable inside this method, so I cannot access the user from outside the test. But with Spock, you can actually. You can put here something, in a closure, in a Groovy, you define a closure with curly braces. A closure is pretty much the same as a lambda with a Java 8 plus lambda. It's not exactly the same thing, right? But for this use case, you can think, or for pretty much everything, you can think in your head that it's like a lambda. So you put here something that you want to evaluate, and this is going to check that an IT is the default name, the default variable for iterations and for lambdas, or for closures in this case. So basically, as this is a user, and we know that user has a name and a last name, I can check that the name of that instant that is going to be created here needs to be Ivan, because I'm passing this name, right? So I can run again this new test. The test is going to pass. And then I'm going to show you what happens if I, for example, change this. I modify the name of the user. And the test passes, sorry, the test fails because, again, there was too few invocations. Let me do this. There was too few invocations for this one, right, with Ivan. But Spock also says, but you know what? There was this unmatched invocation, which is this one, that maybe this is what you want, right? Because this was Ivan, and here you have Ivan too. So maybe this has something to do with the thing you were testing, right? So, and you can put here any Boolean operator, and you can say it.lastname equals or not empty or whatever. You can put any Boolean condition inside these closures. So what else? We can also, in this example, I show you how to mock this interface, but sometimes we don't have control or our dependencies, and we need to mock an implementation. So I have here this email service, which is basically a Java class with this method that prints this thing, sending email to this user with content, whatever, right? Very simple, but this is a Java class. This is not an interface, but you can do the same. You can mock that class, and you can call a method, in this case, in that class with another message, and you can check that this method with that specific message was executed. And if I run the test, you see that the test passes, and there is no print line here with this printout that I had, right? So I'm mocking this implementation. Another thing that you need to do sometimes is checking the order of something. Imagine that you want to send 3 messages, 3 notifications, and you want to make sure that they are sent in this specific order. First the message 1, then 2, and then 3. You need to put 3 then blocks, right? To check 1, 2, and 3. Let's run it. It's going to pass. But if I do this, no, sorry, let me do this again. If I change the order of this, first, the second, and the second one is message 1, the test is going to fail because I have these 3 separated then blocks. And for Spock, every one of them is like test or evaluated in isolation. But if I remove the then blocks and put everything inside the same one, the test is going to pass again, because inside the same then block, the order is not checked, right? I send 3 messages and I check that the 3 of them like arrive. So it's important if you want to do something like this, you use different then blocks. There is another thing that it's and, so you could say something like this, but this is only semantics. And this is useful when you write here something. The message 3 is received, right? And again, I'm not writing here all the labels in the given when then. I only show you in the first example, but you should do it. And I do it all the time in my test. I write this, everything here, a small specification, a small thing in plain English, because it's an easy way to read the test, right? Given a user and a mock service, when I send the notifications, then they are received in the first one, the third, and the other one, right? And the last thing I'm going to show you with this thing is, I have here also this helper method, which is a static method, and return the current time in millis, right? So this thing is going to change for every execution. This is a pretty simple example, but sometimes you have a static method on static classes and even in libraries that you don't control. So the thing I'm going to show you works also for your proper code or for your source code, but also for other external third-party libraries that you are using. And you can mock this static method. For doing this, we are doing this. This is kind of a trick. This is a Groovy trick. So if you don't know Groovy, this is strange. But once you know Groovy, you know how this works. Every Groovy object has this meta class thing. And it's like, so it's like an object, a companion thing in the class, and it contains a lot of things about that class, including all the methods, all the parameters, all the properties, and everything, right? And what we can do is like live patching that method, the current time method, because this is the same, right? Current time in the meta class. So it's not going to modify the code. It's only going to modify this kind of related thing associated to a class, because when dynamic Groovy execute code, the first thing is going to see is going to look for that method, for example, in the meta class. So basically, what I'm going to do here is I just mocking this static method returning 42, and when I call the real method, it's going to return 42. No matter that I have here this current time millis. So this is a nice trick that you can use, and as you see again, without no third-party library, not the external dependency for mocking static, even without anything related to Spock, because this is Groovy thing. Stubbing. So another thing, when testing, mocking was creating like an empty object, and you check the behavior, right? You check that code was called. But with an stub, what you create is like a fake object, and you want to return something when you want a method. Imagine that you have a database call and you want to mock that, and you want to return a fixed value just to make sure that it works, and you do whatever you want with that code. So for that, you use an stub. So I have this user repository. It's an interface. I have here, I think, an implementation, but it doesn't touch. It's just a fake thing. So I imagine that you want to mock this, right? You are using, for example, Grails, or you are using Spring Data, or you are using Micronaut Data, which implement from an interface. Those frameworks implement the data layer access for you, right? So you want to mock that out. So you do an stub of that class, and then you here define a method. Let me do this again. And you need to return here something that matches this signature, right? I need to return a user, so I create my fake user. I use the right zip operator for doing that. And here again, the underscore means that I don't really care about the parameter. So I can pass here a 1, a 2, or a 47, and I will return this same user, right? I'm checking that this user will be John Doe. You can have you can have more than one value for every time you call the method. So here, instead of using write sieve, you use this thing that I don't know how this is called. It's like super write sieve, whatever. You put a list, and then again something that matches the signature, which again is the user. So I put John and then Jane, and I call it this 4 times, right? So for the first time, it's going to return the first element on the list. For the second time, which is user 2, is going to return the second one. So that's why user 2 is Jane. And then I call it more than twice, but I only have 2 elements here. So Spock is going to return always the latest one. That's why user 3 and 4 are always Jane. You can also define different parameters on values. So here you are saying, when I call, you see that I'm defining or I'm stubbing the same method more than once. This is totally fine. And you say, okay, when this is called with 20, please return Jane. So when I call it with 20, which is user 2, it will be Jane. When I call it with 11, it will be John. And for any other number that I don't care, you can see here 99 and 42, users 3 and 4, it will be Peter. So this is pretty flexible to basically do whatever you want. Another thing is testing exceptions. So you can make that this method returns an exception to check whatever you want. Imagine that your method, the method you are stubbing, returns an exception, and you want to make sure that your code responds appropriately to that. You put here inside a closure, you throw your exception, and you can check it as we saw before. This is the runtime exception was thrown, and this is the message. And this last example is pretty much the same. You can stub more than one method, right? In all this example, I was always stubbing the find by ID, but I have more than one method in my interface, so you can stub more than one. You can do whatever you want. It's way flexible. Life cycle. This is pretty simple. There is this life cycle of things that you can execute before your tests and after your test. So setup spec will be executed only once at the very beginning, cleanup spec at the very end, and setup and cleanup before and after every test. So I have here, no, not this one. I have here these 2 tests, basically print test 1 and test 2, and you can see here the output. First, the setup spec only calls 1, then setup, then my test, then cleanup, then another setup for my test, my second test, cleanup, and cleanup spec. So with this, you can instantiate connections, stopping things, create new objects, whatever you need. This is a utility method from Spock, which is useful in some cases. Imagine that we want to check. This is a pretty simple use case because I'm using an array list. But imagine that this is a more complex code. I have my lists, and I want to check what happens, right? That the size is increased when I add a new number. So what we usually will do something like this. Okay, I'm going to save here the size of the list, numbers.size. And then after adding a new element, I want to check that now the numbers.size, so the new size of the list, is equal to the size I store plus 1, right? This is what we'll do in our heads, right? We are developers. We know that we can save something and we can use it later, right? But for us as a humans, we don't think like that. What you think or what you probably have in mind is, okay, after adding the number, I want to check that the value, the new size of the list is the old value or the old size, plus 1, right? This is what you have probably in mind, even if you convert that to the other code because you know how to do that. And this passes, and this adds, or this does under the hood what I did. Spock says this old and thinks, okay, yeah, I need to move this to the given part, evaluate it, store that value, because then I will going to use it, right? So this is not something that you will use in every single test every day, but for some cases it's useful. This is a pretty simple one, but sometimes it's useful to use this. I'm running out of time, so I'm going to show you a few more examples. Imagine that you have here, I'm creating a user outside my tests, right? And I'm printing them. So what happens if this here, this is pretty cheap operation, right? It's instantiating a new object. But if this is a very expensive operation, connecting to somewhere or doing something expensive, you don't want to do that in every single test. But as I have here this, you see the output, right? They are different instances. It's not the same. I want to share this instance with all the things. So you may want to try using this thing, clean up or set up, right? And it works, but it's a way more verbose. So one thing that you can do, it's annotated did with @share. And with that, you are telling Spock, this is only going to be instantiated once, and it will be reused for all your tests in this file, right? So you can see now in the output that the same user is used in both cases. So keep that in mind when you are instantiating here something that is expensive. This is pretty simple. What happens with a test fail? I create a user, Ivan Lopez, and I check that the name and the last name is not that, right? So it's going to fail for both of them, but it only fails for the first one, right? So it only says, okay, I found this failure and I'm not evaluating anything else. So I fix this and then it fails for the next one. And imagine that I have here 6 assertions. So there is one way saying verify all. And inside this closure, Spock is going to verify all of them, right? And it's going to evaluate all of them. And if I have here 6 of them and all of them fail, I will see that in the same output. You can see now the name is not Ivan and it's false because it is, and the same with the last name. So you don't need to fix this thing, run the test again, it fails, you fix it, you run it again, and so on and so forth. And for the last one, let me skip this one because this is way more better. Sometimes you want to run tests based on some condition. For example, you have this @requires or ignore if. So this @requires that the operating system is Linux. So this I'm running Linux, so this test is going to run and it's going to pass because it's just true. And this test requires Windows, and it should fail, right? But as I'm not running Linux, as I'm not running Windows, this test is going to be skipped. You can say something for the JVM version, right? So ignore if it's not Java 8 compatible, or ignore if it is only Java 9, or you can define your own conditions. You put here some static method call with parameters if you want. You can use a lot of things here, and then you return true or false, right? And based on that, this test will be run or skipped, right? So you can see that should only run on Windows is skip, and should be ignored in Java 8 Plus is skip, because I'm running Java 17, so this is not run. And the last one, a timeout. This is a helpful annotation because sometimes you can test that something is executed with some time constraint, right? So I'm here sleeping 200 milliseconds, but I have this timeout annotation saying, okay, if this test takes more than, in my case, 500 milliseconds, I want the test to fail because maybe this is something critical, and I want to make sure that it works. So it fails. Let me run it again. Yeah, it's taking, even if I'm sleeping, it's taking 570 milliseconds, right? So now if I only sleep for, I don't know, or I put here like this, the test probably is going to pass now, or should pass. Yeah, pass. Yeah, now only less than 500 milliseconds. Right, so you get the point. So let me go back to this one, which I skipped, and I will finish with that. Another thing that you can do with this meta class thing is not only overriding method, but adding new methods. So you can say, I'm adding to the string, the Java-lang string class, I'm adding this say hi method, and this is the implementation, hi, and the delegate. The delegate is the value of the string in which I'm calling this. So if I say start of Java, say hi, this is what I expect, right? And if I call it this, so if I run this, it's going to pass because I added this method to the string class, and now the method exists, And if I run the test here, the second one, it's going to throw this missing method exception because this method doesn't exist. Yeah, it's passing because of that, right? The method, the exception was thrown. But what happens if I run both tests at the same time? The first passes, but the second doesn't pass because it says I was expecting missing method exception, but no exception was thrown, meaning that this method exists. And this exists because modifying this meta class affects to the whole execution, right? In this case, the execution is both tests. So for cases like this, Groovy has this nice annotation called confine meta class changes, and you say here, I want to do it for a string. So if I run both tests again, so with this, Spock is going to kind of store the initial state of the meta class, and it's going to restore it after it. So you can see that now both test passes. Remember this one I did here that I should have done the same, confine meta class changes for my data helper class, because it could happen the same, right? You can propagate this unexpected collateral behavior to other cases. So when you run your full test suite, some random test fails, but when you run that specific test that failed, it works. And this is sometimes it's tricky to find why a test fails. So when you deal with meta classes and tricky things like that, you always need to do this. So that was my last example. Basically, that's all I have for you today. Thank you for joining me. I have you have here the Spock framework webpage. This is the direct link to the latest version of the docs. The docs are really awesome. It explains, or they explain everything that I show you here and even more, and with more examples. And here in this page on the JetBrains blogs, Trisha G was doing this series of small videos and blog posts about IntelliJ IDEA and Spock. So they are really helpful. You can see, like I did here, right? Different examples of how to do that and how to use this with Spock and IntelliJ. And that's it. This is my contact information. Feel free to reach out to me if you need anything or if you want whatever thing. If you want to discuss about anything about Micronaut, also feel free to reach out. And I think that's it. If we have questions, I will be happy to answer them. Thank you.
Hey, thanks a lot, Evan. That's a very interesting session. We really loved the examples there on using Power Asserts, and I mean, it came as a surprise that you could do all mocking inside a Spock without having to have like a separate library or a package or anything like that. So that's a real big benefit. Yeah, and we have some questions from participants. So I've compiled some that came through to me over chat. So one question that you've already answered, but still it's there. This one comes from Tarak, so he's asking, is it mandatory to use Groovy, or can we use Java?
Yeah, it's not. So you saw, for example, in the user example, I don't remember what was this second one. I wrote here. This is Java code. The only difference is that you will put a parenthesis here, and you won't put the curly braces, and you can put the semicolon if you want, right? But you can see that I put the parenthesis. Now IntelliJ says this is a mapper, which is the actual name, right? So it's not exactly the same, but it's pretty much the same. If you don't know how to write something with Groovy, you can do this. If you don't know how to write this list, you can do here a list of these values or a new array list or whatever. So it's 99% compatible with Java code.
Okay. And there's another, more, practical question. Is this code, online anywhere for people to refer to?
It's not at this moment, but I will put it. So I will put it into GitHub. My GitHub account is Ilopmar, the same as my Twitter. So I will push it later, so anyone can play with it and try it. I will share with you the link So if anyone asks for it later, you can share with them. So yeah, I will do it.
Okay, yeah, thanks a lot. The other question that I have here is from Piyush, and he's asking if, considering most of the development, these days is around the REST APIs, are there any best practices to keep in mind as far as using Spock in a REST API development environment?
I don't think there is an specific, or I don't think about any specific best practice for testing a REST API than any other different code. As I said, we in Micronaut, we test everything with Spock, even if everything in Micronaut is Java, as I say you here. And in some client projects that I've been doing with Micronaut, it's the same. Java for code, test with Spock, and we use the Micronaut HTTP client for testing, but I don't see any specific best practice that you need to have in mind only for this for REST APIs. It's the same for everything, right? Try to keep your tests as clean as possible, as dry as possible. Create helper classes. For example, one thing I always do. Let me go back. So something like this, right? Instead of putting here all this initialization code, in this case, I'm testing this code, right? But imagine that I need to create this for a list of users for a test. Instead of copying this and putting here on my test, I always put it in another class. I create a trait. So a Groovy trait is like, you say here, you can create here a Groovy class, let's say foo, and it's a trait. And you say here, string foo, return hello. A trait basically is a piece of code that you want to share, is right? It's like a behavior you plug into other class, and I can say here, this implements my foo trait, and then basically Groovy just copy and paste this code into my class. So I can, in any place I can say here, I call it foo, right? So it's available there. So I put all the code, all the helper methods and that I need to create objects, users, author books, anything that I need to create for my test, I put always in traits, and I reuse them, right? Because when you change something, imagine that you create here a user and you add a new mandatory parameter. I don't want to change 60 or 100 tests to add this new mandatory parameter. I go here to the only one place I have it, and I added that, and done. I fixed all my tests. So maybe this, but this is one thing. Put in something like this, all your share code regarding the objects you need to do to create for testing your API.
Got it. And because the other question I have from Harish is given that Spock is Spock sort of embraces behavior-driven development. In an agile environment, does it really help to have something like this, or any thoughts on that?
So the question is if Spock helps in an agile environment to write tests. I mean, it helps. Anything that you can do for writing tests definitely helps, no matter what is it, right? Because it's, as I said, it's really important to write tests. I know that sometimes in the real world, we have pressure, we need to ship it like today. And sometimes we say, yeah, I don't have time for tests. For me, that's not an option. I always write tests, and most of the time I like to do independent on the case, right? I would like to do TDD, writing first the test and then the implementation, especially for bugs. This is really important. When I'm fixing a bug in Micronaut, I write the test that reproduces the bug, and then I'm able to fix it. And I know that it works when the test passes. But yeah, I mean, you don't need a Spock for in an agile environment for doing that. You can write your test in JUnit if you want, right? The important part here is please write tests, right? Even if it's with JUnit. If it's with a Spock, it will be faster, and you will help your past self in 6 months, because you will probably understand the tests better. But the important key part here is write tests, no matter what.
Right. And one last question. This one's about people moving from JUnit to Spock. So, how's the learning curve for people moving from JUnit? Is it steep? Are there any resources for people coming in from JUnit? Something like that, yeah.
Yeah, so you saw the code. I will push it so you can play two dependencies on your test implementation scope with Maven. It's a little bit more verbose because of the XML, but it's pretty much the same. There are a lot of resources there. And I think in this link I shared, I think that Tricia here, I don't know if she uses Gradle or Maven, but you can see there are four parts: getting started, useful tips, stubbing. So I recommend you to check this, and there are small videos, and she explains everything. So yeah, she's also using Gradle, but as I said, there is a lot of resources there about how to configure with Maven. And regarding the test, you saw it's pretty simple: extend from one class.
Correct.
And basically put your test. Instead of annotating with a test, you don't need to do it. Write the method name in plain English. Given when then, if you hesitate, given when then always. Don't need to use expect or things like that. And then go to the official docs. Let me open them here. So this is a single page documentation with everything. You can see here the scroll bar. There is like a lot of documentation here about a lot of things that you can do, right? So it explains everything that I explained and even more. So take a look at this. This is probably the entry point if you want to learn more about the Spock, because it's the official documentation.
Great. And one really last question. This is from, I don't have the name correctly, but yeah. So this one says, would it be possible to do code coverage and line coverage in Spock? I don't know if I get the question right, but that's what it says. Can we do code coverage and line coverage in Spock?
For that, I know that IntelliJ has some features for that, but I've never used that. For that, what I've used in the past is, especially in my Grails project, I use a plugin called Cobertura, I think. There is another one called Jacoco, especially for, I mean, it's not a plugin. Jacoco is a library, and there is a Gradle plugin and a Maven plugin, so you can integrate with that. And once you use any code coverage tool, Jacoco, Cobertura, this one, OpenClover, I think that's another one. There are a few of them. Everything, so all of them integrates nicely with Spock. So you don't have to worry about that. If you already are using any of those tools with the unit, you can still use those tools with Spock. I'm pretty sure they will all work because I've used those, a few of them in the past, especially with Grails. I use that tool, and we have our test reports and our code coverage reports. And in that project, a long time ago, it was with Jenkins, and we will be able to see all the code coverage and everything on the Jenkins UI. So it works for sure.
Great. So that's all, in terms of the questions. But thanks a lot, Ivan. It was a really illuminating session. Very, very practical. I myself, I've been able to learn like so much in terms of how to use Spock, and I can see it's not very hard. So thanks a lot for taking the time out to do this today.
Sure. With us. Thank you very much for having me, and I really hope that everyone learned something new today. And remember, if you need anything or you have questions, don't hesitate to ping me, and I will help you.
Yeah. So thanks a lot, Ivan, and thanks everyone for joining us today.
Thank you.
Thank you.
Bye.
Bye-bye.